Section 4.8, Elliptical Orbits. So if you're traveling at 8 kilometers per second, the Earth falls out from under you at essentially 5 meters every second, and you will orbit the Earth in a circle. Now, if you were traveling faster than 8 kilometers per second, then you will overshoot a circular path, and instead of making a circle, you'll make an ellipse. An ellipse is essentially a flattened circle, right? An elongated circle. Sometimes you call it an oval, with two focal points. These focal points are called foci. A circle is just a special case of an ellipse where the foci are on top of each other at the center. They're the same point in the center. As you flatten the circle out, the foci spread out. So in an elliptical orbit, there's a couple of different things. The distance from the object that is being orbited changes over time. So at some points in the orbit, the thing will be closer, and some points it'll be further away. That means that the speed changes. When it's closer, it's going to speed up, and when it's further away, it's going to slow down. So it turns out that though a lot of our orbits appear or are close to circular as we go around the sun, most objects, as they orbit the sun, orbit in ellipses rather than in circles. The Earth's orbit is an ellipse. It's a close to circle ellipse, but it's still an ellipse. We are closer to the sun in December than we are in July, so we're traveling faster around the sun at that point. Not much faster. The difference is minimal, but it is different. And so we know that these things that are orbiting around the sun, or as objects orbit around the Earth, if they're traveling in elliptical orbits, we know that they have to be traveling faster, at least around the Earth, than that 8 kilometers per second.